Hey there, this is Dan Bader, and this is another part in my Python functional programming series where we talk about what is functional programming anyway, and where you can learn some of the functional programming primitives in Python, like the filter function, the map function. And in this video, we're going to talk about the reduce function. So we're working with a simple data set of scientists and their birth dates and stuff like that, and we're transforming it in interesting ways using functional programming principles. So in this video, I want to talk about another functional programming primitive that is the reduce function. And because I'm on Python 3 here, I need to first import the reduce function from the standard library. I believe on Python 2, you'll be able to just go reduce, and that function will be a built-in that's available in the global namespace. But because I'm on Python 3, I need to actually go from functools import reduce. And then we can take a look at the doc string here again. And so I love this doc string because I still remember the first time I was learning how some of these functional primitives work in another programming language at the time, and just reading the definition of the reduce function. In like my first year of computer science education, I was sitting there like, I have no idea what you're talking about. And well, I hope you don't feel the same, but if you do, then don't worry, because you can figure this stuff out. And hopefully that tutorial will be a part of it. All right, so let's go over this. So the reduce function, it takes a function, and then it takes a sequence of stuff. So I believe for the map function and for the filter function, those were called iterables. So kind of the naming is a little bit inconsistent here, I guess. But basically, the reduce function takes a function, a sequence, and then an initial value that I believe is optional. And it reduces the sequence down to a single output value by applying this function repeatedly to the items in this sequence. So the way that's expressed in the doc string is a little bit more complicated, but we're going to take a look at some examples here that actually go back to our data set. All right, so just to make sure you see what I'm talking about here. So this is the original data set that we were working with. It is an immutable data structure. So there's a tuple of other named tuples. So each item here is a named tuple. That way we can make sure I can't reach in here and accidentally modify any of these items or the whole structure. All right, so we're going to take this and we're going to do some experimentation here with our reduce function. So the first thing I want to do here is I want to calculate the total age of this group. So if you remember what we did in the last installment of the series, we did something like this, where we calculated this derived list that had the name and age of all of these scientists in 2017. And so I'm actually going to use this derived list for the first example here for using the reduce function. So what we want to do here is we want to calculate the total age. And for that, we're going to use the reduce function. And we're going to define a lambda function. I could also do this outside with a regular function, but here with a lambda, I think it's appropriate because then, it could be really declarative and it could all just fit into one short expression. So here, what I'm going to do is I'm going to define a lambda that takes two arguments. The first one is the accumulator. The second one is the value. Let me type this out, and then I'm going to talk about what these individual parts mean and how they work. Maybe you can figure it out as I'm typing out this function. So this lambda function is going to be applied repeatedly to all the items in this list. And so val will always be the latest item that we're looking at. And the accumulator will be sort of a running variable that gets updated repeatedly. The return value of this function will be the new value of the accumulator. So I know this sounds crazy, but this allows us to do something like this, where we can say, okay, reduce this names and ages thing down to a single value using this rule here, this lambda. And we're going to start out with an initial value of 0 for the accumulator. So let's run this, and then let's take a look at the output. Okay, 807. So this should be the sum of all of these ages here. And let's talk about how this worked. What you can see here is we have this lambda function that is the function that the reduce call applies to all of these items. And the way it does it, it picks an initial value for the accumulator that I set here. So initially the accumulator will be 0. And then it calls this lambda here with the first item. And you can see here that we're returning the current value of the accumulator, which is 0, plus the age field of this item here that gets passed in. And then in the next round, well, the value of the accumulator was updated. So at this point, it would be 202. And then in the next round, we're taking this item here. The value of the accumulator is 202, and val is this item here, this dictionary. And now we're adding together the value of the accumulator and the value of the age field in this dictionary here, and we're returning that, and so on. So this is how we boil down this whole list into a single integer that represents the sum of all of these names. Now in Python, again, There are other ways you would represent this particular calculation. For example, I could have gone like this and said sum of X age for X in names and ages, and that would have done the same thing in an even more concise and nice representation. So at this point, you might be wondering, okay, why do I even need to use the reduce function in this case at all? And the reason is that the reduce function, it can actually go far beyond what you've seen here. So we can talk about some pretty crazy examples here. Why don't we look at some more interesting uses of the reduce function? All right, so one interesting thing that I thought we could do with the reduce function is grouping scientists by field. So basically, I want to have some output like this. I want to fill this up, this dictionary here, and I want to populate it with the scientists grouped by their respective field. And we can do that by creatively using the accumulator field, right? So what we're going to do here is we're going to define a function that we can pass to the reduce function that will take our existing list of scientists and assign it to these fields and kind of group people that way. And so the way we're going to do it, there is actually a way you can do this in a single lambda expression, but I just started recording that example, and it was like, man, this actually really detracts from what I want to show you here. So here I'm just going to define my reducer function, and it's going to take the accumulator and a value. I'm just going to say, okay, in the accumulator, well, you want to look at the field that this scientist belongs to, and then we're just going to append the name of that particular scientist. And then, of course, we need to return the accumulator. So you might be wondering, what is that? What does that do? You're going to see that in a minute. So here, I'm now typing out the reduce function call. So I need to pass my reducer function, and I need to pass my scientists, and then I need to initialize the accumulator. And so here, this is where this thing comes in, because we need to make sure that this dictionary here actually has slots or has these keys in here for all the different fields, so that the reducer can go over it and it can update the accumulator according to the individual field that each of these scientists belongs to, right? So now, once I've run this, let's print it out. And yeah, you can see here it worked. So for astronomy, I've got Vera Rubin, chemistry, math, and physics. They're all kind of sorted that way and assigned to the right categories. And I hope you can see how this worked here with this reducer function. And the main thing you need to figure out is what I was struggling with the most was how these names like accumulator and value, how they correspond to actual items and what the accumulator looks like as it gets updated, right? So that's like the biggest thing you need to wrap your head around. And it makes sense to play through this maybe even on a piece of paper, or certainly here in the Python REPL. One thing that I really don't like about this is that I have to give it a list of categories up front that then gets populated. That's kind of stupid. And if I make a mistake, I have a typo here, then it's just all going to blow up. But there is a better way to do it, and that is the default dict class in the collections module. So I'm going to have to import collections. And what we're going to do now, I'm going to overwrite this scientist by field object here again. I'm going to pass it my reducer function. I'm going to pass it the scientists. And instead of initializing the accumulator, I'm going to go collections.default dict of list. And then what that will do, I'll show you that in a minute. What that will do is it will lead to the same result, because this collections.default list thing, or default dict thing, is pretty magical. So let's just create an instance of that class. So this is a default dict. And now this thing, every time you access a key that doesn't exist, it will be created and it will be populated with whatever you pass in here, whatever factory function you pass in here, right? So now I can go and I can put all these crazy keys here, and the dictionary will be updated. So now I can do stuff like xyz dot append, and this will work because it's going to create that slot for me just in time. And I can keep doing that, and it will keep updating, because now from the second call on, it knows that it has this field in there in the default dict and it doesn't need to recreate it. So this is like a little trick you can use to get around having to manually define the accumulator here. But of course, it's also adds more complication to this function call. And I'll bet you like this would actually take many people a while to figure out and to read that. And so that's actually a pretty good reason to not use that in production code. However, I think it makes for a really interesting thought exercise in Python. And I think it's pretty cool to work with these different kinds of programming paradigms and programming styles, like functional programming, object-oriented programming, more like a procedural programming. And it makes sense to be comfortable with these different styles, because even if you don't always stick to any one style, 100% of the time, you're going to learn a lot about when these things have their strength and when you should apply them. And I think that is really valuable, and that's going to put you above and beyond what most people do when they learn programming, right? So I think there's a lot of value in exploring these things. All right, so I want to end this reducer example with another, well, arguably more Pythonic version of what we looked at previously. And you can see I played with this a bunch because, well, this here is called Scientist by Field 5. It's basically trying to come up with ways to do this grouping in better and more readable ways. And so now this is based on a dictionary expression. And this kind of fits the theme that happened in the other videos in this series as well, where I showed you kind of the classical functional programming approach and then showed you a more Pythonic version where we're often using list comprehensions or generator expressions to get to the same result, but kind of do it in a more Pythonic, more readable way. I'm not sure if that's the case here. Like, I'm not sure if this is more readable, but you can do it. And there's actually a helper function in Python that is itertools.groupby function. It does stuff like that. It can group things by a key func. So here I'm grouping these items by their field, and then you have to do some fiddling here to get the keys and the value set the right way. So, I mean, arguably this is more Pythonic because it uses a dictionary comprehension, but I'm not sure if this reads much better. But it gets around the need for the default date. So, I showed you a couple ways to do it. I'm sort of tempted actually to drop this crazy lambda expression here on you. But you know what? The hell with it. I'll just do it here. Okay, so this is what I came up with. Scientist by field has the same result, and it uses a lambda function instead of a separately defined reducer function. And it also uses this dictionary merge syntax available in Python 3.4. But this is pretty gnarly and crazy code. I mean, it works, but when you look at this, it gets very, very arcane. So please don't write code like that when you're working with other people. Sometimes it's fun to sit down and spend some time to try and come up with, I guess, like a single line solution for this problem. But this is more like a fun exercise rather than something you should do in practice and for production code. But anyway, I hope this gave you a better idea of what the reduce function could be used, and maybe also some ideas on how it could be used in more creative ways to achieve that grouping, for example, and not just for the classical examples where, you have this here where we're adding up a bunch of values and kind of boiling it down to a single integer, something like that. So I hope we achieved that. I hope you learned a bunch of things about functional programming in Python here. And at this point, you should have a pretty good understanding of what functional programming is, what the filter, map, and reduce functions are, which are kind of the core primitives of functional programming, how they work in Python, and how you should probably not use them in Python or use them in different ways, for example, by replacing them with list comprehensions or generator expressions. Happy Pythoning, and have a good one.